The weird thing about in mathematics, everyone agrees. Proofs generate agreement in a way that uh, religious dogma, for example, does not, or anything else. I pointed out that in mathematics there are corrections and retractions. And I said what happens in theology is not corrections and retractions, or in other social practices like how where your fork is supposed to be and things like that. Instead, you get splintering of practices and you get a kind of evolution.
Hello, my geeslings. This is Mother Goose Robinson Earhart here with the Podcat pins and also the introduction to Robinson's podcast, number 75. This episode is with my friend Jody Azzouni, who's professor of philosophy at Tufts University. And while Jody is best known for his nominalist stance in the philosophy of mathematics, I actually don't know if that's true. He's best known to me for his nominalist stance in the philosophy of mathematics, and it's my podcast, so I guess I have license to say that. But anyway, he's also an author of fiction, essays, and poetry. And that's relevant because in the beginning of this episode, we talk about one of his poems in great detail, the process, the language. I have some challenges to him. He has some challenges to me. And at the end, we also talk about another poem, one that he didn't write, actually. But sandwiched between this discussion of poetry, we also talk a lot about the philosophy of math. And more particularly, we talk about the distinction between natural language, so French, English, Spanish, formal languages like set theory, first order logic, this sort of thing. And then there's also mathematies, so the sort of math you're used to seeing if you're not a mathematical logician, in which a math paper is a mix of symbols in English. We talk a bit about this because it's of pretty immense philosophical importance. And then the roles and varieties of proof in mathematics, and then whether math can have foundations. And there are actually a lot of other little mini questions we go into. So let's see, math as a sociological practice, math as a science in the way in which it develops. But that's most of what we talk about. And I should also mention that this is Jody's second appearance on the podcast. He was also on episode 45. And there we go more into his nominalism and the debate between nominalists and Platonists in the philosophy of mathematics. Nominalists are one breed of philosopher of mathematics, though there are nominalists in other areas who don't believe that there are mathematical objects, whereas Platonists believe that there are bona fide mathematical objects that exist in some salient and important sense of the word. Then I should also say you should check out Jody's website, which is jodyazzouni.com, naturally, and you can find his fiction, poetry, essays, and philosophy there. Just as aptly named as his website is his latest book, which is Attributing Knowledge, What It Means to Know Something, and the title of which seems pretty and, as I've already indicated, quite laudably self-explanatory. I must now make my quote-unquote call to action. So please leave a review, a comment, a like, subscribe, those sorts of things wherever you're listening. And check out Robinson Eats if you want to on Twitch and YouTube. And then I'm not wearing my special fancy t-shirt that you can now purchase on robinsonsfashionempire.com, but you're probably not going to do that, and you should not feel obligated to. Not that I could make you feel obligated to or enforce any such obligation, but it's there. And without any further ado, I hope you enjoy this conversation as much as I enjoyed having it with Jody. So the last time we talked, as much as I love talking about philosophy of math, I found that my favorite parts of our discussion were about your poetry. So before we started, I sent you an email asking
That's
if we
right.
could start again with one of your poems, and I chose the ones we talked about last time, and I asked you to pick one this time.
Right.
So what poem are we going to be talking about?
Okay. Well, the one I picked was a poem that got published in the summer of 2018 in Poetry Quarterly. Uh, it's not like my favorite. It's a poem I like, but I wouldn't call it my most favorite poem or anything like that.
Mm-hmm.
I don't have anything like that. But it's fairly recent, so I thought that might be of interest because the poems you were reading, I was reading from that you were talking about, were all from The Lust for Blueprints, which was published 2010,
Mm-hmm.
right? The last issue, something like that, 2001 actually, I think, so quite a while ago. So this is much more recent. I don't know if it's going to seem different or what. So anyway,
What's this
I
one
guess I
called?
should just read it.
Well, what's it called first?
Colored themes.
Colored theme. Okay.
1. Color has many moods. The suspicious blush, perhaps of rose or something else, the squish of a definite pink across the sky, and of course the Venus, full of cloud cover, spotted with rash. Ice, faintly blue, faintly transparent. Even that's a color. 2. The spatial habitats of color, its ways of spreading over the surfaces of things and never being one place, one time. 3. Who knew glass would be so strange way back when everywhere there was only sand? Who knew that brown and rust would melt transparent, go invisible like a soul? 4. And all the unsensed new colors, something to see after we're something else. That's the poem.
Yeah. Can you read the last stanza for me again? I
Sure.
liked it.
4. And all the unsensed new colors, something to see after we're something else.
Afterwear is one word.
No, after we are, except I
Oh,
abbreviated. After we
I
are something else, after we're something else, is how I would say
I
it.
see.
Something to see after we're something else. Yes, not entirely transparent, the sound. But if you were reading it, it would be, I think, clear.
Yeah. A number of things jump out at me upon hearing that, and I haven't read it before. The first is how much more, at least to my ear, it's transparently philosophical compared to the two poems that we read of yours earlier. Do
Oh,
you feel that, or do you not?
um, yeah, I don't know.
To me, there's like an immediate, obvious connection to your nominalism, like the connection between colors and things.
Oh, you see, because I'm like thingifying color, as it were.
Yeah, exactly that.
Well, see, that's what I would have said. I mean, how is the poem's aesthetic operating? I guess if somebody pushed me and asked me that question, as I've just asked myself that question just now, I'd say, well, I'm kind of spatializing color, treating it as, you know, uh, oddly on the surface of things and yet not at the same time. And that's kind of what I'm exploiting. Now, I guess that's philosophical. It's hard to say.
I
A
think it's
kind of
pretty easy to say.
what?
I think it's pretty easy to say that it's philosophical.
Okay, I mean, uh,
You can disagree.
well, I'm not disagreeing. I'm simply, you know, I mean, I look at the poem as it were, and I think to myself, um, I certainly didn't write it thinking philosophical. I wrote it because of the way the imagery came together for me. That's one of my primary motives. But I had this kind of conversation, off and on for a few years with Mario de Caro, who basically said, "Oh no, a lot of your poems are very philosophical." And I'm like, okay, you know. Um, um, I'm not sure. That's all. So I'm not disagreeing with you at all. I'm just saying, the problem is, and this is always a problem in a way, sometimes I can't even see what a short story or a poem that I've written feels like in a gestaltish sort of way for years. It takes a couple years. And then I come back to it, and then I'm really almost, that's how long it takes for a certain aspect of my memory to go onto the back burner. So that I'm reading it like it's a fresh item almost. Of course, it doesn't look unfamiliar, but at least I have access to the gestalt. And then I'm often surprised. Oh, that's how that comes across as a whole thing. Because I didn't see it when I wrote it. I almost never see things like that when I'm writing them. And that's true with this poem as well. I'm sort of seeing this flavor now of, oh, okay, it's kind of doing something interesting with, color as landscape almost, something like that. I don't know if that would work 100% because the third stanza, who knew that glass would be so strange, et cetera, et cetera. I mean, that's doing something slightly different. But anyway, I don't have a problem with saying it's philosophical.
Yeah. Well, usually, I mean, before jumping to any sort of on a first reading, when I'm reading or listening to a poem, I'm trying to get maybe a feel and see just what it evokes in me. But it's not until after I've read it many times that I would want to propose an interpretation or
Fair
articulate
enough.
one.
Yeah.
But I really do like the point about glass that really jumped out at me. Do you remember how that came to you? Or how long ago did you write this?
Not that long ago. Maybe 2016, 2015.
Okay, well that's long enough for me that I would have no idea how that came about. But it's a really nice turn of phrase and a really striking idea.
Yes, I mean I've played with glass for years in poetry. You have a copy of you have access to a poem in Lust for Blueprints, which is called Wintertime. And that's playing with the imagery of mirrors and glass breaking and the images coming out of the glass. That I wrote, Wintertime, I wrote like I was 20 or 21. So what would happen is certain kinds of visual phenomena would pulls together for me. And then I want to, I'll end up revisiting and writing poems about it. And often it's something like this because, the striking thing about glass, and this is the striking thing about chemistry anyway, is you have substances that have one set of properties, and then you do something to them, and you've got an emergent property, what looks like an emergent property coming out of nowhere. Now, of course, it's not coming out of nowhere. And we can now say, in many cases, quite a lot about why the resultant molecule or whatever the structure of the mixture is that emerges, why it has the properties it has, why it looks the way it does, et cetera, et cetera. Although, like in the case of gems, this is very subtle. But from a poetic point of view, when you're kind of just thinking about it, here's the phenomenology, here's something, the way it strikes you. Things like sand to glass are very, very, I don't know how else to put it, poetically exciting. So that's where it comes from. So I have that's almost like, you can find that if you go through my poetry over many years, you can say, yeah, he's quite taken with this, this kind of visual phenomena.
One of the exciting things about poetry, though, is how in such few words, it can really transport you somewhere very far from where you are. And in this case, I mean, glass is utterly quotidian for us today, but I can imagine a few thousand years, I don't know the history of glass, but a few thousand years ago being surrounded by a desert of sand, and then you see glass and it really has this like celestial, godly almost property. And I can also just imagine why people were so fascinated by the prospect of alchemy. If you can turn sand into glass, then maybe we can turn lead into gold. That doesn't
Of
seem like
course,
such a huge jump.
that's exactly right. The fascination was due to that, and in a
Oh,
way,
actually, historically.
um, no, I wasn't
Oh,
saying that.
okay.
Not
Okay, okay,
sand to
okay.
glass. Well, you can do that with, but the kinds of transformations that people had run across, and then the particular way they were theorizing about it, um,
Hmm.
certainly made it a very exciting thing to try to pursue. And, yes, turning something into gold. But
Yeah.
there are lots of things like this in the world where to us now it's completely dull. And you have to realize how fascinating that had to be. For example, our reflections in water. If you think about
Oh,
that,
yeah, absolutely.
you realize, the first time, whoa, what is that? Oh, that's me. Oh my God. No, but it isn't just me. It's something else. It's something else doing
Yeah.
something.
Yeah.
No, that's, what's the claim about philosophy? Who said this? Philosophy begins in wonder. I forgot. Is that Socrates? I don't remember who's supposed to have said that first.
I have
Um,
no idea.
yeah,
Philosophy begins in wonder.
yeah.
Let's
And
find out. It begins when I'm
Aristotle?
not seeing who said it. Maybe, yeah, it
Well,
looks like Aristotle actually.
okay.
No, Plato insists that yeah, Plato.
So is it a misquote? Well, of course it's a misquotation because it's English instead of Greek, and the word may not be exactly the same word, blah, 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 blah.
Yeah, yeah.
But anyway, I always thought, and I've made this joke, I may have made this joke in print, which is I said, no, philosophy begins in bewilderment. That's what it really does. But poetry, for me, often begins in a kind of wonder, a primitive kind of whoa, where I recapture or re-see something that would be imagistically shocking to us.
Hmm.
And then I play with it. And yeah, that's a common technique for me. Seeing those
Another.
things and then having that reaction. Um, in fact, I kind of collect them. That's how I'll often have a whole bunch of these, which I'll call images, right? And I say, it's time to write a poem. So I'll pull these things out of old folders and everything, spread them out on the floor, and see if I can get something to coalesce into a poem.
Hmm.
And there are certain images that stay with me for years. In our last podcast, I talked about the Odin poem that way. Odin gets to see it all. There was images that had just been with me for a decade by that point. And then I finally found a way to make them work in a poem. You have to be patient. Well, like philosophy, you have to be patient and wait and hope you're still alive by the time you
Hmm.
get around to actually coming up with something.
It is it's fascinating though. I mean, that you have to be patient with a poem when a poem can just be a few lines. You would think that that's something that you could just jot down, whereas with the philosophy article, I mean, a lot of thought and revision has to. It's obvious that you have to put that thought and revision into it, but it's not so obvious with a poem to the outside, because especially now, since people are writing in free verse and you're not having to worry about syllables and stanzas and rhyme schemes, it just, from the outside, it seems like these things should just be, you should be able to just smatter them down on
Well, I
text.
mean, I get it, but of course, one of the things I try to do in all my poetry is I want them to be structured, as intricately structured, in a certain sense, as artificially structured as traditional poems were. Only I'm not really doing it with the sound, except insofar as my poems always have these rhythms in them, and I know they do because I keep tinkering until I feel comfortable that I can say them aloud. Until I can say them aloud comfortably, I keep
Hmm.
messing with the sound pattern. But the structure now for me is mostly in the images and the intersection of the play of thought and or sometimes the voice of the narrator, et cetera, et cetera. And I know a lot of contemporary poetry doesn't do anything like this. It is, in a certain sense, quite unstructured, as unstructured as ordinary prose. No, there's also lots of prose writers, of course, where the prose is very, very structured, very aesthetically complex. Even stuff that reads very simply. I'm just going to mention Fight Club by Palanchuk. I don't know if I'm pronouncing his name right. If I am, if I'm not, I apologize to him since he's still alive. But the point is, when you actually make sure you can hear the way that very simple looking dialogue is going down on the page, you realize it's highly structured rhythmically. That's the kind of thing that, to me, that's one of the marks of a great writer, or at least that's what I would aspire to. That kind of thing.
And this makes me want to ask, did you just stumble upon this idea that you should be able to speak your poems out loud? Or have you also done a lot of reading and thinking, guided, I suppose, is the distinction here, on how to construct poems?
No. The following happened. In fact, again, if you go back to the early poem Wintertime, you realize that can't be read aloud. How on earth would anyone read that aloud? It's like there's at one point I say, well, I'm going to write between the lines of the poem. And then I do. You can't say that aloud. For me, at that stage in my life, up until my late 20s, poems for me were primarily visual objects on the page with words, of course.
Mm-hmm.
And then what happened is I started going to poetry readings to read some poems in the New York area and at that point, I wanted to be able to say the poems aloud. And I said, I can't say any of these poems I've ever written aloud. I just can't do it. So I started working on trying to do that. And apparently for me, saying a poem aloud, something that I want to call a poem and saying it aloud, it wasn't going to read like prose. And I can't answer the question why. Why was I requiring myself to have the poem have the kind of rhythmic structures that they have before I would be able to say it aloud in a public forum? I can't answer that question. But that's what happened. And so there was a transition period, some of which is represented in Lust for Blueprints, because Lust for Blueprints is all the poems that had been published up to the time I published the book, they appear. And so there's a kind of evolution. And you've got the ones that are not to be said aloud. You've got a few in the middle where I'm obviously honing things. And then you've got the stuff later when I said, okay, I can say this aloud. Same thing with the prose, by the way, my short stories. I have to say them aloud. I have to be able to read them aloud.
Now, plenty of poets, though, E.E. Cummings comes to mind as a very well-known example. Their work is, in many ways, primarily a visual object. I mean, if you struggle to read an E.E. Cummings poem out loud, you're going to miss a great deal. So
that's correct.
What is it about your writing where you don't necessarily want it to just be a visual object anymore? You want it to be something that is audible, I guess, or hearable, or
well, I want it to be both, which is,
okay.
I don't know if poetry can serve two masters, but that's certainly what I've been trying to do for a very long time. And again, you might ask, well, why? Why do you want to do that? And the answer would be, well, that happens to be the particular kind of aesthetic object that I'm exploring, I'm trying to create. Those are the ones I like at this stage in my life, or since I was 30, or even a little younger. I mean, part of what's going on is again, now I'm talking about the short stories and the fiction. My stuff, my fiction and short story work is very, very affected by dialogue constraints. I'm a dialoguist. You may notice that a lot of novelists are monologuists, really, and even when they have conversations, it's like monologue followed by another monologue, followed by another monologue.
Right. Yeah.
And it's funny because I came to prose writing through plays. I loved reading plays. And for me, dialogue is a back and forth. It's challenge, counter challenge, or not even challenge, counter challenge, commentary, comment, responsiveness, because the parties are listening to each other. Again, something that happens less often than you would like in normal conversation, especially with family members. That aside, the dialogue matters, and what's really important in capturing dialogue is a kind of something for the ear. The ear goes, yeah, that sounds like people talking, as opposed to that sounds like nothing on earth that I've ever heard. So that's playing a role. So it's clear there's a complex, in my aesthetics of writing, there's a complex interplay of how does it look on the page and what does it sound like if you say it aloud? And I want both of those,
Mm-hmm. Well, there are a few more things I'd like to talk about the poem before we get to the philosophy. And one more philosophical aspect of the poem that jumps out at me, and this I feel is probably less intended and more something that I'm reading into it, is that fourth stanza about all the unsensed new colors. And the reason that jumps out at me as philosophically relevant, one, the connection between the perceiver and color, and I mean there's a lot going on there, but I just spoke to an astrophysicist on the podcast, and we talked a little bit about false color images. So all of these pictures from the Hubble telescope, or now the James Webb, that we've looked at, I was thrilled by them as a kid, only to learn that we're not actually seeing images of space or quasars or galaxies, whatever, that the human eye could detect. It's really like X-rays or gamma rays or something that are this, and the spectrum is sort of shifted to, I don't know if it's the left or right, but maybe to the left, into visible wavelengths. And there are all sorts of unsensed colors out there. But it's interesting. I mean, what is a color then? If it's something that you can't, if it's not in the human visible spectrum, is it still a color? Is that even the right
well,
category for it?
I don't see why you don't want to say it's a color, at least for some of these things, some of these forms of radiation, and I really doesn't want to get a lot of. Okay, let's leave those aside. Let's just note the fact that bees, for example, I believe, this is something certainly I read a while ago. I think it's right. Bees see ultraviolet.
Right. It helps them discern flowers, I believe.
Yeah, and birds have a much wider range. Most birds have a much wider color palette than we do. We're based on 3, right? They're based on 4, and I believe in some cases 5. So I wasn't thinking, I mean, I think what you're talking about is in the ballpark of what I was thinking. But of course, what I said was something to see after we're something else. And my thought is, of course, if we evolve into some other kind of creature, or we manage to biotech ourselves there more quickly, one of the upshots will no doubt be seeing a wider range.
Yeah.
Okay. And I don't see any problem with calling them colors.
Mm-hmm.
Okay, so that's what I'm thinking of, and I think so. You're right, but I would say there's no issue with calling them colors. That's just what we'll call them if we're looking back on, those poor humans. what a limited color palette they had to deal with. Can you imagine how awful their interior decorating was? Ugh.
I have no idea how one would begin to answer this, but it's raised a fascinating counterfactual question to me. How humanity would have evolved differently, culturally, scientifically, if when we looked up at the sky, we hadn't only had access to our current um, visual spectra, I guess. Like if we had looked up at the stars and not seen just the stars, but quasars and galaxies and all these other sorts of things emitting different aspects of light.
You mean if
How
we
that?
had a broader visual
Yeah,
capacity?
yeah. That's exactly what I'm saying.
Yeah, I mean, as I tend to be kind of negative about counterfactuals, not because, you
What do you
know,
mean negative? Like you think they're useless?
well, actually, yeah, I kind of do. I don't think counterfactuals as they're used in science are useless, but this is going to take us to a more technical conversation. I
Mhm.
actually don't think they should be handled along the lines of logic, actually. But let's not go
Yeah,
there.
yeah,
Um,
that's fine. I was just
but
it's just like just a fascinating thought. I wasn't thinking that it was
right,
something
but the thing
we
I
should
was
be
going to get
philosophizing
at
about.
is when you start to entertain these kinds of counterfactuals, it's hopeless. It's hopeless to imagine what it would be like because, it's hopeless to try to figure out, well, what would change and what wouldn't change? How do I set this up? How do I look at the causal trajectories?
Well, I'll push
So,
back against you and say that I think you're totally wrong in some
okay.
sense. In some sense, just because I can imagine a wonderful sci-fi movie that goes back in time and imagines what it would. So it's wrong maybe to try to get a factual answer, but it
Oh,
can still be
yeah.
very fun. Yeah,
Oh,
that I'll
it would
agree
be
with you.
enormous fun, and I could come up with a
Yeah.
half a dozen movie
Okay.
scripts. No
Perfect.
problem.
We're on the same page then.
We're on the same page. It's just somebody says, answer that question seriously, not
Yeah.
not don't answer it for MGM entertainment. And I'm like going to
Hmm.
go, I can't.
Yeah.
Neither can
Okay.
you.
Right. Okay. My last two questions about this poem. One,
Sure.
why did you decide to structure it the way you did with these four parts?
Oh, can't answer that question. I don't know how to answer that question. That's a genre. I almost call it a subgenre in poetry. I've done it not a lot, maybe 6 times, 7 times, different poems, where I number them. And that's something people do, or some people do. I don't know. I was almost thinking of it a little bit as jazz. You're kind of here's a way of playing with the theme. Here's a different way of playing with the theme. Here's another way of playing with the theme. And I think I don't remember what my earliest poem was where I did that. And then I didn't do it again for a decade or so. And then on occasion I do it again. Somehow the poem invites it. And then I structure it that way. So there are questions you're asking, kind of, which are often like, this is what I was reaching for aesthetically to make the poem coalesce for me. And it worked. And that's
Hmm.
often the answer. That, at least it's the answer I have. I don't have any deeper access to what's going on with the maneuver.
Well, you said you couldn't answer the question, but I think you gave a great answer, and I'll paraphrase what I heard, which is that some things we just have to take as maybe primitive or unanalyzable in the poet's or the artist's process. I mean, it was just an
Oh, I don't want
intuition.
to say that. I disagree with that.
Oh, oh,
I'm
okay.
just telling you I can't do it or I haven't tried. I'm
I
not
see.
I am not claiming that someone might not come along and say, "Look, here's what Azzouni," because of course they would talk about me using my last
Yeah.
name and not my first name. Um, they would say, notice that the times that Azzouni did this were these cases, those cases, those cases. Notice there's a pattern here. Notice that, in point of fact, it never happens with these guys. And they might come up with something. I just haven't done that or tried to. I'm not at the age yet where let me look back upon my work and see, anything nostalgic. I don't want to do that. I'm not doing that. That much introspection I don't need.
That's fine. Okay, and then the last thing you said, that this poem, that you wrote it based on how the imagery came together for you.
Mm-hmm.
Now, did all of this, everything we've just talked about, come out of like a literal snapshot of a landscape that you had in your mind?
No.
Or what? Okay. So
Yeah, that's not
what do
how
you
it
mean when you
works.
say how the imagery came together for you? You
Well,
had these ideas.
it does coalesce into a kind of landscape where the landscape is a visual depiction. Not all my poems are like that. Again, one last week that I read. You made me read. Let me put it that way.
Forced
Odin
you.
Gets to See It All is a narrative, but it ends with a snapshot of look what Odin is seeing. This poem is more like the one that I just read, or a little while ago, actually, now. This poem kind of is a landscape, as it were. Here are ways of thinking about color. Call it a semantic landscape, if you will. And no, that I don't start with that. I finish with that. I'm sitting there trying to get the poem to work. And, I'm like, this doesn't work with this. This doesn't fit. This doesn't fit. And then suddenly, oh, okay, it's done. I've got it. And then sometimes I don't know why I think it's done. It takes a little time and I go, oh, because here's the landscape. Here's what the poem did. Got it. Okay. So it's like that. Does that help? Did I answer your question?
It does.
Okay.
No, it does. It does. No, this was really fun. It's great to talk to a poet about their work and hear about your process. But now we get to talk to Jody the philosopher.
Okay.
And what I had in mind, starting with, now we've talked about some of these topics or adjacent topics last time, but I wanted to talk about speaking mathematics in natural and formal languages. And before we get into that in some depth, I think it would be nice, because not everyone listening is going to be a logician or a philosopher of mathematics. So I wanted you to maybe say what a formal language is and what a natural language is, and how they're different, I suppose, because they're quite different.
I'll start with the natural language. Here's the picture. The picture is a natural language is a species-specific ability that we have, humans, to generate this highly syntactic, structured, semantically rich thing, these sentences. Okay? That's what a natural language is. And so it's an empirical question. This is the key point. It's an empirical question, to my knowledge, still barely understood. Maybe it's unfair. Maybe we understand a lot more about it now than, but what its syntax really is, what is going on semantically. It's
so structure
all
empirical.
And meaning. What?
I was just saying structure and meaning, roughly,
structure
for people
and meaning,
who don't
yes.
know.
Now, a formal language.
Well, first, I just want to make sure we're on the same page. So, English, French, Spanish, maybe even Esperanto. Maybe we'll call those natural languages. But when the cat meows, that's not a natural language, because it doesn't have the syntax or the semantics that we
That's correct. Now, there's another
with natural language.
That's right. There's another important writer, which is, you're talking about English, French, Spanish. Technically speaking, there are no such things. There are only the idiolects of individual Spanish, French, English speakers, which are sufficiently similar that we overlook the differences. And we have, now I'm speaking Azzouni-ish a little bit here, we have the involuntary experience that we are speaking a common language. You and I are having the involuntary experience, not that I'm uttering idiolects and processing what your sounds in my idiolect and vice versa. our experience is that we've got a public language going here that we're both conversant in and participating in, but there is no public language. That is, if you want a hallucination, a group hallucination, because we grew up under sufficiently similar language experience conditions that our idiolects are close enough. Okay? So that's what a public language, that's what a natural language is. Okay? Now, a formal language is a syntactic and semantic, an item with grammar and semantics, but it's invented. Not only is it invented, I credit Frege with the invention of the first one. I think that's right. I think it's him.
In the Begriffsschrift, so
yes.
Concept script or concept writing.
Right. So I'm not focusing so much on the final codification of logic that, he's credited with. I'm like, yeah, logic, that's cool. Really, what's important here is artificial language. And what's an artificial language is what I just said. It's something that looks like a public language. It's got syntax. It's meaningful. However, it's mathematically, now I'm going to use this word and then qualify it immediately. It's mathematically transparent. Now, of course, nothing is mathematically transparent because sometimes it takes a lot of work to show that something has properties. But the point is, we stipulate what the syntax is. In English, we don't have a clue. And depending on the way you go here, you stipulate how the sentences are given their interpretations.
Right.
Okay? So all that is mathematically given to you. Now, this is the first artificial language. Computer languages, we have thousands of artificial languages now. In fact, the important thing about us, post really 20th century on as opposed to before, is we don't simply work with natural languages, we work with artificial languages. So was that good? Did I get across what I think an artificial language is?
Yeah, I think you certainly did.
Okay, good.
Yeah, that's perfect. Now, could you also say a bit about why these languages are, in general, sort of important for mathematics? Like maybe how they functioned with early set theory, maybe Russell, Hilbert, that sort of thing. Because formal languages, while, most mathematicians don't use them, most mathematicians are using mathemates or something like that. It's a mixture of English with symbols. There is a very distinct and perhaps not as thriving as some would like it, subdiscipline of math logic that focuses on studying mathematics through these formal languages.
Okay, yeah. So there's a couple things going on here, right? Which you've noted. One of them is that there's a way in which, very successfully, it is a success story, we transcribed the mathematics, classical mathematics, say up until the time of the very early 20th century. We transcribed all of that mathematics, which was taking place in natural languages, augmented with vocabulary, forbidding mathematical vocabulary, and we transliterated it into formal languages, and in particular one formal language, but it can be transliterated into a number of them. That was a success story, and there was a bit of philosophizing about how that happened. So, for example, the thought could be, well, natural languages already had that logical structure in them, that logical structure built into them. That's why this transcription was successful. I think that that's actually false. As we learn more and more about natural languages, the question of what their logic is, or their logics, or whether that's the right way to think about how reasoning takes place in natural languages, is very hard to understand. But it's clear that I think you've got a picture like this. I don't know if you can see what I'm doing here is a kind of Venn diagram.
Yeah, I can see it.
And basically, here's the formal language. Think first order predicate calculus. That's a particular one. Think natural language, and they kind of overlap in their expressive properties. There are things you can do in one that you can't do in the other, and vice versa. Okay? But it turns out, interestingly enough, in the core, in the middle, the overlap is what we do in mathematics. Okay? Now, there's another study. Okay, this is one thing. This is like, what language are we carrying mathematics out in? What languages can we carry mathematics out in? The other thing that's going on is, of course, the mathematical study of formal languages. In addition, the mathematical study of formal languages and their interpretations. And this is just mathematics as usual, with a particular subject matter. And that includes things like, infinitely long sentences, logics like that, various kinds of logics, how their properties intersect, formal languages, how their properties, what they have, et cetera, et cetera. But it's really just, mathematics the way that if somebody is studying the real line, it's a piece of mathematics. Okay? So those are the two. Right.
Mm-hmm.
Now, the main thing that I worry about is the former topic, okay? The former topic is where are we doing mathematics and how are we doing it? And that's what I have been focused on for many years. I just kept going back to it and going back to it. I never tried to really officially write a book about it, like other topics that I was working on. And but I kept worrying about it because there were views, a way of focusing the issue is focusing on what's a mathematical proof.
Yeah, and these are things that I would like to get to them, but there are precursors though that I think we should talk about first.
Go.
So one I just wanted to clarify to hear what your answer was. You said that much of mathematics was translated into one
transliterated. I kept avoiding translated.
Okay,
I didn't want to use that word.
Why?
Transliterated. We basically we took the mathematical subject area, in particular the theorems and the notation, and transliterated it into a formal setting. The proofs get transformed dramatically when you do that. But the process ends up being conservative. And that was the striking fact. We didn't discover that there was mathematical results we couldn't get, that we had in the informal topic. And now we don't have it anymore. We don't have them anymore. That was a successful transliteration.
I am not quite understanding the distinction between translation and transliteration and why you want to avoid translation so much.
Because I'm scared of the idea in translation. I'll put it this way. In translation, you're supposedly capturing meaning. I do not want to swear to the claim that you're doing that.
I see.
By the way, for kind of the same reasons.
Oh, very interesting. Very interesting.
We don't go there. We don't talk about this. We talk all the time, poetry again, of translating. Oh, yes, so-and-so translates poems. When you become conversant in two languages, which I briefly was for a while with French, the horrifying experience is looking at translated poems, even great ones. You do not preserve meaning. Or if you do, you lose so many other things. I don't think poems get translated. I think you create a new object in a different language that is causally connected to and maybe inspired by the original poem. So I take this very seriously.
So it's this idea of not carrying over meaning is very interesting. And so now I understand. Now it's sort of like if you're taking Hebrew to Aramaic or something, you could just sort of mechanically copy one thing over to the other because their letters are similar enough, maybe, without having to go into a sort of semantic analysis of what's being spoken.
You mean
or
because the
written.
languages have changed that little?
Yeah, because they're so similar.
Okay, then that becomes possible. But if you've got languages with any distance between them at all, natural languages, only certain sentences can be translated, literally translated. And usually you don't get a sentence, you get a paragraph, because, natural language words, they just are bundled together differently. I'm not even focusing on the issue of sound here. That it creates additional problems, of course. But any case, when you've got a formal language, there's a real question of, this might get too technical to start to focus on the first order predicate calculus and talk about the connectives and, or, not, and so on. But those, I'm pretty certain, are not their natural language equivalents.
Right. Certainly not the conditional.
Not the conditional,
which is a good example.
Certainly, but I also think this is true even of or and and. You can try to do a kind of Gricean style save. Right? Should I explain that?
Please.
The trick is something like this. Look, you say something like, John brushed his teeth and he got out of bed. And there's a kind of implicit, in English, we kind of think, oh my God, he brushed his teeth in bed. There's a temporal linkage, but we can cancel it in English. We can say something like John brushed his teeth and he got out of bed, but not in that order. Okay. And
yeah, exactly.
What?
Exactly. Yeah.
Yeah.
No, that's
so
such a
that
good example.
Temporal order looks like, well, that's what and in English means, but really it isn't what it means because we can cancel it. So that makes the and look much more close to the formal analog, but I don't think it works ultimately. And what I think is interesting, what I think happened with mathematics. So my story, I have a very complicated story, which you certainly don't want to hear the whole thing now. A very complicated story about why mathematics was able to be transcribed to a formal language. Because I think once you start to see that these things really aren't the same, have the same properties, you have to answer that question. You have to say, how did that happen? And I think, yeah.
No, I was going to say that I really actually do want to hear the long story, but this is a very brief interjection, and why I brought this up in the first place was I was wondering which language you were referring to when you said that so much of it had been transliterated into another language. Were you referring explicitly to like the language of piano arithmetic or the language of Zermelo-Fraenkel set theory, or more broadly you were thinking predicate calculus or first order predicate calculus?
I was thinking of if it's going to be the predicate calculus, you're going to have to transcribe it first order, and you're going to use Zermelo-Fraenkel set theory.
Okay, so that's what you had in mind.
That's what I had in mind. But of course, that's not the only possible first order theory. You can have first order theories with any number of ideologies.
But that was the historically important one you were pointing to.
That was the historically important one. And actually, it's Principia. It's higher order logic. But then
type
there's
theory.
this complicated relationship between higher order logic and first order Zermelo-Fraenkel set theory, or first order some sort of set theory. They are not logically equivalent, but there's a way in which you can capture the mathematics in either of them. This should start to give people a pause who are thinking, oh, well, natural language mathematics, it's just one of these. It's none of those. And what happens is there's a making do process where you can capture this that way. And it turns out what you're capturing is pretty much all the mathematics you want. So that's, excuse me?
No, you can finish. Go ahead.
Oh, well, so that's what's going on there. But you still have to tell a story about how it's happening. And one of the important aspects of the story, especially if you're working with classical systems and classical logic, is you're going to look at, the connectives. And you want to know exactly how is it that the other properties of connectives, in quotes, in natural language aren't playing a role. And sometimes the answer to this is humorous. Like, here's an answer I actually think is there. If you think of your mathematical objects as platonically, as time, out of time and out of space, and causally neutral, you're throwing away as relevant a lot of the semantic structure of items in English, like the properties of the horseshoe, like properties of and. You're kind of semantically stripping the thing down when you're doing mathematics. The motivation is subject matter, but the upshot is, you're ending up with a body of sentences that are transliteratable more easily into a formal language.
So is that the short version of the long story you were getting into?
Yes, that's the short version of the long story. Yes.
Okay.
Or rather, it's a version. It's part of it, because I'm telling you this is a bit about the connectives. So it's giving you an aspect of how proofs in natural language, mathematical proofs, can be transliterated into proofs in a formal medium, why the connectives aren't running interference. You still have to explain things about, the differences between a formal proof and what's going on in natural language proofs. Right. Mm-hmm. The main important thing is that in formal proofs, you've got a mechanical recognition procedure for recognizing the proofs. It's checkable by a computer. You don't have that in natural language, or rather, you have it only with little small pieces of it. And that's the other thing. That's the other aspect of the long story you have to tell.
Got it. Yeah. Before we get into the proof side of things, just a bit of a higher level question about this distinction between the formal languages and the natural languages and doing mathematics. So you mentioned that in a formal language, everything is designed. It's very rigorously laid out and defined, so we understand the connection between the language on the one hand and the models on the other, and what makes a given sentence true or false. It's all stipulated.
It's all mathematically set up. Exactly. So there's nothing empirical here.
Right. Since naive set theory we know is inconsistent, then what does it mean we're really talking about when we talk about set theory without specifying that we're referring to some specific formal system? Like maybe perhaps even before we know that there are axiom systems, how do we know whether what we're saying is true or false?
I'm going to speak from my own point of view. I think if you're a Platonist, you've got a real issue here. You've got a lot of hard work. And I think at the end of the day, it's really not going to work out for you. So I prefer to speak as a nominalist. And I think in that particular case, what we're talking about are languages. Okay. Now, it may be that when you go way back in your history of mathematics, when they're talking about triangles and things like that, they've actually got physical objects in mind or diagrammatic objects in mind. That is certainly a possibility. And, the Babylonians, the ancient Egyptians, I don't know. But the point is that in that case, you can talk about what's true and what's false because you've got real objects that you are talking about. But what happens once we go Platonistic, what's happening is we don't have real objects anymore that we're talking about. The languages are extremely useful. And now what you need to focus on is the question of what are the properties of those languages? Why are they useful? In applications, I mean. And what do the successor languages look like that follow from the earlier languages as people tinker and modify? This is the kind of thing that certainly was going on explicitly in the, at least by certain practitioners, in the movement from naive set theory to eventually one or another formal set theory. What was happening was you were lifting things out of the naive practice that you wanted to retain. Part of what was motivating a lot of people was the Principia Foundationalist program, some kind of program where you want all your mathematical objects to be kinds of sets, which means you need the right existence claims and things like that on your set theory to get those things. And you want it to be consistent, so you don't want to help yourself to an unrestricted comprehension axiom. Okay. But what I think everything can be explained in terms of the properties of the languages. And you don't need to talk about the rabbit hole question. Are these the same objects? Are they different objects? Are they related objects? Are they cousins? What are they? So that's my quickie response.
Okay. Well, thank you for letting me sort of sidetrack you from the question you raised earlier that you're focusing on, which is where are we doing mathematics and how are we doing it? So maybe we can turn now to proofs. And again, in general, for our non-mathematical audience, what distinguishes mathematical arguments, proofs, from those in other fields? Like, why, when we're talking about mathematical argument, are we talking about something that is definitely distinct from what might be being done in physics or a courtroom where people are also making arguments?
Well, I mean, physics to some extent has shifted a little bit on this, but the thing that I think is strikingly different, and there are going to be philosophers who disagree, but the thing that I think is strikingly different was the thing that I think Plato noticed, which was that mathematical arguments were utterly convincing if you understood them.
Yes, and you could, and that's important.
And that's really important. And no other arguments anywhere seem to convince anyone of anything. You always had these, and Plato was in particular concerned about the moral realm, arguments about ethics. But it was perfectly clear that arguments there weren't convincing. And Plato, I think, is the first, and this continues, but I think it's really, really important, to try to answer the question, what's going on with mathematical proof that it has this very strange property? That the arguments are convincing. And I mean, that's the thing that's true to this day when somebody learns mathematics. I mean, they learn two things usually, unless they're, one of your facile child prodigy types, who finds mathematics easy. There are two things. One of them is that it's very hard. Okay. The other thing is that when you get it, it's utterly convincing.
Mm-hmm.
And you're not finding those kinds of things anywhere else. So that's a property that needs explaining.
Yeah. Justin Clark Doan, who is a friend of mine, I know you talk with him a fair bit as well. He has pointed out to me that there are sort of two distinct things about a mathematical proof. On the one hand, you have what you just described, what he calls like amino style proof, in that it really explains something to you and it's convincing. And then the other half is that it really conclusively shows something, this conclusiveness of a mathematical proof that you don't have in, say, a courtroom. These are two of the real distinguishing properties of a mathematical proof.
Yeah, I'm going to resist the first one. A
Okay.
lot of people like this. There's a lot of literature on explanation in mathematics. In fact, there's a lot of literature that focuses on trying to distinguish and mark mathematical proofs. They're both proofs. You're convinced by both of them. But in one case, you get you get something. You go, aha, that's why. That's why this is the case. In the other case, you go, you can't resist that because every step is right, like a computation. So you can be convinced of that as well, with the writer that maybe you made a mistake. But apart from that, if you see if the computation is short enough or clean enough or anyway you're kind of good at this, you'll go, no. This can't be wrong either. Now, I think it's a really, really deep question that I have not started to play with. Why we feel that certain kinds of things explain other things and when they don't. I have a lot of deep-seated suspicions about this. Most of this takes place on the intuitive level. Hey, look at this proof. Don't you feel it explain things? Oh, yes. And I'm not denying the pull of that because I feel it as well. But this is phenomenology. This is how we experience certain kinds of proofs. And I'm not utterly convinced that there's something, I don't know how to put this, metaphysically / logically solid about a purported explanation. So, I mean, I'm suspicious of the concept. But again, this you should not push me on because I have not written about this.
I won't push.
I'm heading towards it, as it were. But I'll simply, point out, that a lot of people draw the lines the way Justin does and see this kind of difference. And I'm primarily focusing on the phenomenon of why we're convinced, because here's a quickie explanation for why I was focusing on that, because there are philosophers of mathematics who think, well, that's not real either. That's a sociological phenomena due to training or due to this or due to that, that you're convinced. And I don't think so. I actually thought there was something really solid behind it, okay, that made mathematical arguments different. Should I spell this out a little now, or do you want to?
What I was going to ask then, and I think this will lead into the answer that you were going to give, is that there are multiple kinds of proof in mathematics corresponding roughly to this distinction that we drew earlier between natural and formal languages. There are formal proofs and informal proofs, and they're treated very differently. So I just wanted to make sure which you've been talking about and which you are talking about
I'm
as you're
talking
answering
about
this question.
what we call informal rigorous mathematical proof, which is the professional mathematical proof that shows up in journals.
Right. The kind that is not done, though, in an explicitly formal language.
Right. The proofs in an explicitly formal language, actually, almost no one ever uses them or even sees them. You practice them when you take a logic course. You actually write them down. But it's not, even if you are a logician studying logical systems, you don't write those things down. You write down informal, rigorous, ordinary mathematical proofs.
Mm-hmm.
Okay, so it's important to realize that real mathematics, that's where it takes place, not in a derivation, not in a formal setting, almost never. Okay,
Mm-hmm.
so anyway, back to the question then. What is going on in informal rigorous mathematical proof? And in the, I guess, the 20th century, the go-to position for a long time was that informal, rigorous, ordinary mathematical proofs were simply abbreviations of formal derivations in one system or another, in one formal system or another. That's why they had the properties they had, because in point of fact, they are, and now I'm going to use the language that I got associated with, indicating they're indicating a formal derivation. And you see that when you read the informal proof. You kind of see the formal derivation, and that's what epistemically convinces you that has to be true.
Yeah. Mm-hmm.
The only problem with this story is that it doesn't explain the phenomenon. This is really the worst, the problem with it, because when you actually take the thing and write it down as a formal derivation, when you take an informal proof and try to write it down as a formal derivation, well, first of all, there's more than one way to go. But second of all, the thing that you get is not convincing. It's only convincing in a step-by-step, I didn't make a mistake in the calculation sort of way. It's not convincing in the way that the original proof was.
Right.
So it's not explaining the phenomenon. Okay. Now, I'm going to just cut to the chase and tell you what my answer is. I mean, it's worked out in horrible, horrible detail in a very long article that the powers that be were willing to publish anyway, despite its size. This is becoming more and more true with a lot of my work, unfortunately. Anyway, the answer is that it's right on the surface of the mathematics. You look at an informal proof, and first of all, what you get is a patchwork. That's what it looks like. There's some nasty calculations. They'll be there. They can be there. There'll be some considerations in natural language. You go, yes, yes, that's convincing. There'll be things where you go, yeah, that has to be right. I'm not going to look at it in any more detail. Okay? So you've got a patchwork. But what contemporary mathematical proofs look like is they're a body of little algorithmic systems, little mechanical systems that you manipulate. Whenever calculation comes up, this is obvious. So there'll be some result where you'll say, oh, this group is the same as that group. And to prove it, you actually do a brute calculation, right? And some people will look in the details and some won't. But the brute calculation tells you they're the same group. And then you go on. That's an algorithmic system. You're manipulating, as it were, almost tokens. There's another way in which this comes up. You write down a bunch of axioms in an informal idiom, right? Natural language. You'll say 0 is a number. You'll say the successor of a number is a number. And what you're doing there is you're encoding in the axioms certain words, number, 0, etc. And then the axioms constitute a little algorithmic system, and you manipulate it. And you get results that way. So what is convincing about the mathematics is these little mechanical algorithmic systems, lots of them, right on the surface of the mathematics. Okay? With a kind of expressionistic or ontological claim that this all ties together. That can be proven formally. Then you transliterate it into a formal system, and you go, yep, it's one topic area. we can unify it all. But in the informal mathematics, it's these guys. Is that clear at all?
It is. It is.
Okay.
It is clear at all. But my next question is, I mean, we've talked about, we've just been talking about how and why these informal proofs are convincing, but should they? Should they be? Are there things that we should be arguing about? I mean, or that we should be paying much more attention to? I can see you're ready to speak.
Yeah, and the answer is no, of course they should be convincing. But what are they convincing of? They're not convincing. They're convincing, as it were, of linkages. Assume this and you get that. Assume that and you get this other thing. Okay? And built into your assumptions are basically, to speak in formalese, axioms and the logic. Is all this open to modification? Of course it is. Alternative logics, the big discovery of the 20th century. Lots of alternative logics. Alternative axiom systems. Even with the same logic, you can have different kinds of set theory. You can have different kinds of number theory. You can have all sorts of things.
This is why I was going to say we might have found informal proofs inconclusive, because they are not stipulating which logics we're appealing to or which.
I think they're presupposing it. So I run an argument in a paper. I can tell you the title someday, or if you ask me, I'll go look for it and I'll figure out the title, where I make an argument that the implicit logic of mathematics up until the 20th century was something in the neighborhood of the first order predicate calculus. Certainly classical, not intuitionistic, etc. And I think an argument can be made based on, the kinds of steps that they were allowing and their understanding of certain kinds of operations like negation. So, yes, there's a real, which is not to say, as I said, I don't know, way back when, it's not to say that this is the logic of natural language. That is not the claim. But the claim is that mathematical practice coalesced essentially on something in the neighborhood of the first order predicate calculus. If I can make that case, then that's all you need. You don't need that it's explicit. You just need that this is what was going on. Okay? And then, of course, come the 20th century, all hell breaks loose and you can change it. Mm-hmm. And ultimately, the guy that I kind of agree with on this is Quine, who basically says, yeah, we may decide that our science requires a different logic or certainly a different mathematics, et cetera, et cetera. It's all up for grabs in that sense, and I think that's right. I don't think there's anything in this sense of a priori. I don't think there's anything like that here. We might change it.
I'm not sure if this is entirely related, but you've written about what you've referred to as the heterogeneity of mathematical proofs, and it seemed to be something that you were concerned about. So
concerned? No.
Yeah, am I wrong? Okay.
No, I'm not.
Well,
what I was pointing out was something else. Look, so there is this old tradition, right, from the modern period and before, that if you're going to look for the source of a priori truths, look thou to mathematics. It's full of them. Mm-hmm. And accompanying this is the idea that a mathematical proof is the way that Descartes described it. You really get down to understanding it. You've got this seamless movement psychologically from premises to conclusion. You just see it in one continuous motion psychologically. And then you have the thing that Pfefferman pointed to, this aha phenomena, which often grips you with an entire proof. Not too long, hopefully, but a certain size proof, you go, I get it. and then the details are just details. What I'm focusing on when I'm talking about the heterogeneity of mathematical proof is that the bread and butter proofs, most of the proofs don't look like that. They look like all sorts of things together. That's the point. That's just a fact. So I'm not upset about it. But it pointed me to my claim about mathematics on the surface being a lot of different algorithmic systems. I think that's what the heterogeneity is indicating. And also, I think the heterogeneity is showing you that your kind of a priori feeling, that phenomenology of, oh, you know, this has to be because that is, it's piecemeal in any longish proof. So that's what I'm claiming.
I have a related but somewhat disconnected question to what we've been talking about, largely because of its relationship to the formal languages. But you wrote a paper called "Is There Still a Sense in Which Mathematics Can Have Foundations?"
Right.
And that title is very provocative. And maybe, I mean, that's a really big question, but I guess to me, it seems like an answer to that question, or what it would mean for mathematics to have foundations, would be for there to be an agreed upon language, and like Zermelo-Fraenkel set theory, and
so an agreed upon interpreted formal language, or
right.
And
model, I was going to say, in which we could encapsulate all of mathematics. And is that sort of what you have in mind when you ask that question? Is there still a sense in which mathematics can have foundations?
And my answer was no.
Okay, yeah, I want to hear that. Does it? Well, I mean, my first guess would just be, since you're a nominalist, there is no such model, or there is no mathematical universe.
That's not to me. That's not the problem.
Okay,
I think that the answer to this question is independent of your ontological predilections. Okay. I think the problem is very straightforward. I think that mathematics will always transcend any ideology. Certainly it'll transcend any language. Okay, formal languages because of Gödel phenomena. Okay. But I actually think ideologically it'll do so. That is to say, the way I see advances in mathematics occurring is, you know, we've found this wonderful shiny object, sets. And we thought, oh, we can include all mathematics in it. But of course, you know, there are two issues. One of them is people can keep inventing other mathematics. Let that side of it go. The other thing is, of course, it's incomplete. And it's incomplete in a way that there are certain salient questions that we go, well, we'd like an answer to that. But of course, the system is incomplete. So a quick answer is to just add the thing in one way or the other. That's not an interesting way to do it because it doesn't get you very much in practice. What's going to get you something? What's going to get you something is a whole raft of results when you take your system and embed it in another one. My view is that when you're done embedding it, if you really get something that's exciting, it's not going to look like sets anymore. It's going to look like something else, something we hadn't even thought of. Okay? So that's my quickie answer, is conceptually, ideologies are usually processed by us conceptually. Numbers, sets. Numbers are these objects with certain kinds of properties. Sets are these other kinds of objects. And it's a bit of a shocker if you go and think about numbers. Oh, they could be sets. Or, you know, this is similar to me talking to you about sand and glass. You want to recapture the feeling that, you know, the way we were thinking about functions at one point, which was an operation. And then you go, oh, don't think about it as an operation. Think about it as a collection of ordered pairs with a certain property. Well, you know, that ought to be breathtaking. You have to try to recapture that. And that's the kind of thing that I think will continue in mathematics. And in that sense, there can't be a foundations. There isn't going to be a coming to the end of this. So that's my claim. That is not a formal argument, right? That's me telling you this is how I think it's going to go.
Mm-hmm.
Okay, and this is why.
So you're playing the role of the soothsayer.
I'm playing the role of
the soothsayer. The
yes,
fortune
I'm playing
teller.
a little bit of the role of the soothsayer. I mean, on technical grounds, I win simply because of alternative logics and all of that stuff. You can't pull all that together in one place, right?
Unless you resort to like the set theoretic multiverse,
right?
Something like
right.
that.
But I'm actually thinking, no, there's something more dramatic to point out here. A certain way that I believe that mathematics is open-ended conceptually. Now, of course, I could be wrong, and now I'm going to bring in views that have been associated to some extent with Chomsky. Look, we may be, in ways that we don't quite understand yet, conceptually limited. If we are, it could be that we've hit the ceiling on what we can understand. The mathematics could go on, but we can't go on with it. So then you might end up in a situation like that. Yeah, I mean, I don't think that's correct, because I think there are things to say about how concepts work and how human concepts, are open-ended. But that's another very long story. And again, I want to resist that story because I haven't said enough in print.
Yeah, no, sure. You mentioned before we started that you are currently teaching a course on the philosophy of math at Tufts. So granted that the semester's only a few weeks in, what sort of topics have you been covering, just out of curiosity?
Well, right now in the last couple weeks, I gave them, and this is not a surprise, I gave them some readings, included Aquinas on What There Is and Benaceref's Mathematical Truth.
I am surprised that On What There Is in there. Well, just because that's not a distinctly mathematical paper.
No, it's not.
But it does introduce ontology.
Well, the first half of the course, the first module, is Platonism and nominalism. And you really can't do Platonism and nominalism without talking about Quine's criterion. You can't really talk about Quine's criterion, or the Benaceref paper for that matter, unless you talk about formal languages, natural languages, and set theory, and the foundationalist program that came out of set theory. So that's what I've been doing.
It's interesting, though, that you would say that you can't really talk about Platonism and mathematics without talking about On What There Is, which, I mean, that came out in 1948, and clearly there were lots of discussions about Platonism before then, but maybe...
Absolutely.
Okay.
So what you can do is, what I did was that I started out by talking about the issue almost in Plato's terms, quite a bit. But then here's my claim, and historians may disagree with it, there should be already emerging historians of analytic philosophy. It's been kicking around long enough for this. Okay, I don't know who's emerging this way yet. But the thing I want to say is that what I eventually want to talk to them about is Platonism and nominalism, mid-20th century on. And for that, yes, Quine's criterion is needed. Okay. So that's my quickie explanation. I haven't gotten to talking about this yet. It's, I signed it, a couple weeks ago, but I'm still talking about the history and the technicalities, and I'm talking a bit about model theory. So that's what's going on at the present moment. And I'm trying to do so in a way that you don't have to be trained in model theory to understand this, to understand what's going on. So I may have taken on more than I can by doing this, but that's what I'm trying to do, is get
It's
all
funny
this across to people, even
that's
if what?
I was just going to say, it's funny. That's what I was going to ask, was how you teach a course like this to people who might not have a sophisticated mathematical background.
Well, I was requiring them to have taken a logic course, but you realize in a logic course you almost spend no time on the semantics,
Right.
which is ironic in a way, because most of the philosophical action subsequently is in the semantics. In and I almost feel people ought to be learning more of that in the beginning course. But so that's what I'm doing. I'm assuming of the class they have the logic, and I'm spending a bit more time on the semantics. And as you can tell, that's a centerpiece of Benaceref's article. So I have to, motivate, Tarski's success, as it were, both as a starting programs of semantics, both in natural languages and in formal languages, how that happened, and then talking about, okay, how do we get ontology out of this? So that's kind of what's going on.
There are two final threads that I wanted to ask about in the philosophy of mathematics, and one was I had the mathematician Michael Harris on the podcast from Columbia. He's a number theorist on, and we talked a bit about this.
I've actually met him. He probably doesn't remember me, but I met him a bunch of years
imagine
ago.
You two would get along really well.
Okay.
He's I really like him a lot too. But he and I talked about mathematics, which he describes as a way of being human. And you've written about mathematics as a social practice. And I'm wondering, people don't often think of mathematics as a social practice. They think of it as people sitting in their attics crunching numbers. But what makes mathematics a social practice for you? Why do you perceive it that way? And is it unique in this sense?
Excuse me, the last bit was?
Is there something uniquely social about it? I mean, like a social dimension it has that other disciplines don't? I mean, one thing that comes to mind just is that mathematics is spoken in a way in a universal language, not necessarily the formal languages, but even, yeah.
It is universal, but that's not the way that I'm thinking of it as social. So I may end up answering your question in a way that's oblique to it, what you intended, and then you'll just ask it again. But
sure.
To me, once you get rid of this a prioristic prejudices about what you think mathematical proof is, and also you don't overrate the importance of being a prodigy, where this is accompanied by a certain kind of facility, you simply will focus on the fact that mathematics is hard. And if it's hard, it helps to have friends. People talk to each other. Do you think this proof is okay? Do you think this bit is okay? And that's the kind of thing that makes it intrinsically social. If it's a matter of inventing, which I think it is, inventing and implementing new kinds of algorithms, those are not intrinsically items that you work with in a closet or by yourself. You interact with other people. So that, I think, makes it fundamentally social. Okay? Did I answer the question in the spirit it was asked?
Yeah. No, I think you did. I thought that you might have had something more definitive of mathematics in mind when you wrote about it as a social practice, like something that differentiated its social aspect from that of other fields.
There is the weird thing about, in mathematics everyone agrees. Proofs generate agreement in a way that religious dogma, for example, does not. or anything else. And I did talk about that at length in a paper. I pointed out that in mathematics there are corrections and retractions. And I said what happens in theology is not corrections and retractions, or in other social practices like how where your fork is supposed to be and things like that. Instead, you get splintering of practices and you get a kind of evolution, often unbeknownst. Whereas in mathematics, the splintering that took place is really quite strange. I mean, that's the sort of thing that emerged starting with intuitionism and things like that.
Yeah, I was going to bring up constructivism.
Yeah.
As
there it started to happen, but it's not as if an intuitionistic mathematician can't do classical proofs just as well as a classical mathematician can. Brouwer is a case in point. So nobody is losing touch with what a proof is, whereas that is a way in which other social practices really do evolve and are affected. So that is a difference, but that's not something that makes mathematics not social. It's amazingly so.
Now, how though does this thesis, I mean, how strongly are you committed to it? Because I mean, a few counterexamples come to mind, like involving computer-assisted proofs, like the disputes over the solution to the four-color problem, or there are disputes about very highly technical results in like new foundations, which is studied by a very small amount of people, or in set theory. But there are serious disputes there among experts who know these topics better than anyone else. So there are
disputes about whether something is a proof or not.
Yeah,
I think those are resolvable. Okay. I don't deny that there can be such disputes, but they will get resolved. I mean, either by filling things out or recognizing that there was a genuine indeterminacy here of some sort or whatever. One way or another, it'll get resolved. That's what I think. I think these kinds of things have happened in the past. They are moving targets. They may lead, in certain cases, they lead to alternative mathematics. But the key point here is alternative mathematics is just mathematics. It's not something else.
And the last thing that I wanted to talk about, you already pointed to a bit when you mentioned splintering and constructivism. And this question involves reasoning in mathematics and whether or not it changes and evolves. So I've spoken with Chaim Gaithman of Columbia and Justin, who I mentioned earlier, about this, and they have differing views. So Chaim thinks that mathematics is essentially the same, and there have been no revolutions in mathematics, whereas Justin thinks that what the Greeks did and what we're doing today are completely different disciplines. And I'm wondering where you fall in this spectrum and how it relates to the evolution of mathematical reasoning.
I'm more with Gaithman.
Okay.
When you think about the algorithms have changed, and the subject matters in a certain interesting way have changed. That may be a funny thing for a nominalist to say, but I see processes of embedding structures and richer structures, basically languages and richer languages. But as far as reasoning is concerned, I think it's the same old thing. And I like to study reasoning in the mathematical context because I think it's the same old thing across the board. So I'm focused on that. Now, that said, there's a lot of complexity in what's going on with reasoning. But the quick answer is I'm with Gaithman. And I think you kind of get blinded by the invention of new kinds of subjects to talk about and prove things about, into thinking, oh, well, we're not doing the same thing at all. And in some sense, it's clear we are doing the same thing. And there are always these mathematicians who come along and kind of illustrate that with themselves. They work here, and then they switch to there, and then they switch to there, and then they switch to there. You know, they work extremely broadly, and there have been there's still these they emerge, and that's hard, and most mathematicians don't do that. But I think that's an indication at the level of which it's the same thing. Mm-hmm. Okay. By the way, to say it's the same thing is not to say it's the same thing psychologically. I'm not claiming that at all. Mm-hmm. Okay. I'm sorry, this is all sounding enigmatic, but maybe that's okay at the end of an interview.
Yeah, no, it's okay. No, this has again been great. We really covered a lot of between the last episode and this one, we covered a lot of the mathematical topics that I wanted to get to, and we'll have to leave metaphysics and epistemology to a third installment if I can get you to come back. But for now, I'd like to turn to another poem that you've selected, and I asked you this time if you would pick one that you enjoyed from a different author.
Right. So what I did was there were two ways to go, of course, which is there were all these poems I love over the centuries, like, tons of things from Shakespeare and so on. But what I decided to do was look at some of the recent journals, both that I've been published in and not, and just pick something out, look it over and say, yeah, here's a poem I kind of liked. And I don't even know if the poet is well known or not well known or anything. It's just a poem that I saw. So that's what I'm giving you, if that's okay.
But is it one that you really liked?
It's one that I really liked.
Okay. Yeah.
Yeah. All right, I liked it. I mean, yeah, I'm not reading a poem. Here's a poem. Some person. I didn't like it very much either, but that's what's out there. No. So this is from the Aurorian, fall winter 2016-2017, and I don't even know. I'm sorry. I'm going to betray such ignorance. I don't know if his name is Giles, Goodland, or Giles Goodland. It's Giles.
Or Giles Goodland.
Or Giles Goodland. It could be. I don't know. But whoever he is, or she, I'm not even sure it's a male name. What do I know? Okay. I'm terrible with names. I can't pronounce my last name the way it's supposed to be pronounced. I can't pronounce it. I mean, somebody did that for me. What?
I'd say Azzouni.
No. It's in the ballpark of Azzouni, but the A is this sound.
Oh, it's not Italian?
No, it's Arabic.
Oh, I was giving it an Italian spin.
Oh, you're giving me an Italian pronunciation. No, you could have done that too,
yeah.
But no, it's an Arabic pronunciation, but which I am incapable of. So, anyway.
Okay. So what's this poem called?
It's called February, which
and it's again
I just
one that
realized
I haven't heard yet.
It is February. I didn't do that deliberately.
Quite apt.
Yeah. Okay. February's ruins were bulbing upwards when we walked the churchyard, minutiae rusting the wounded ground. Blackbirds clacked, a vague wind vespered, dirt ordered itself as ice lid. Ice sight that waits only to melt, the playground swing ground to a halt. Until the snow the forecasters spoke of did not arrive, nor winter's Anschluss succeed.
That's all of it. That's short and intense.
Yeah.
Anschluss. That's a German word.
Yes.
What does it mean?
I don't know. You told me to read the poem. You didn't tell me to interpret it.
Anschluss.
I can figure that out. That'll
joining
take 2
or connection.
seconds.
The annexation of the federal state of Austria into the German Reich. So maybe that's not the right word. Are you looking it up too?
Yes. Good Lord. I didn't expect it to be political.
Yeah. Well,
This is, just in case, again, I want to point out, this is 2016, 2017. So there's
yeah.
no allusion to COVID, no allusion to, the contemporary setting. It's winter. So winter is being analogized to a certain political event and not the other way around, I think.
Yeah. Something that immediately came out to me, even on the first line that you read, was it was so nicely spoken, and a poem that was meant, or at least, I mean, I don't see it as a visual object and I haven't read it, but it was certainly a coherent, audible object.
Right. Well, you were asking me to read a poem. There
Yeah, yeah,
are some
yeah.
there are some small trickeries in how the stanzas break. Um, okay. I mean, I can point out, um, the first stanza ends with a period, the wounded ground, period. So now you start again, blackbirds clacked, etc., etc. But then you have, as ice lid, ice sight, new stanza that waits only to melt. The playground swing ground to a halt, new stanza, until the snow the forecasters spoke of did not arrive, etc. It's mild trickery, but there it is. So yes, there's
Um,
something for the eye as well as for the ear, but it's mostly for the ear.
but I can see. I mean, I can see why you picked it, Sids. You mentioned with your own poetry, you don't feel satisfied until it's something that can be spoken out loud, and that
That's
was
right.
one that lent itself to that.
That's one that,
Another
well,
thing,
that's what I was doing when I was looking through the poems. I wasn't just reading them and saying, "Oh God, I'm excited by what's." I read it aloud
oh,
before, since you asked me to pick a poem that
yeah.
somebody else's poem that I was going to read, and that's what I did.
Another thing, I mean, your poem was more abstract, and this one was more concrete, but it was also very much about imagery coming together.
Mm-hmm. That's
This
right.
one.
That's right.
Now, two things I'm curious about your feelings. How you feel about the word vespered?
Um, I liked it. I liked the whole phrase, a vague wind vespered. In fact, I liked that whole bit. Blackbirds clacked. We've been there. We've certainly run across clacking blackbirds in poetry before.
Yeah, yeah,
But
that
a
was something
vague
that did.
wind vespered. Yes. Dirt ordered itself as ice lid. Yes. And in fact, the beginning is what pulled me in. February's ruins were bulbing upwards.
Yeah, and I mean, this is the I'm putting on my literary snob critic hat, but the vespered to me, I guess as somebody who's like sensitive to language, it was just too out there, too novel. It drew too much attention to itself. And so same with
Oh,
like the blackbirds clacked. But you didn't feel
oh,
that way.
no, I didn't feel that way, but I have a different tendency. Uh, um, I mean, I don't know how much you feel my work does that. But my focus is, remember, what was my reaction to the blackbird um,
We've been there.
clacked? Been there, done that. That was my
Mm-hmm.
reaction. Yeah. And so that stood out to me because my own feeling is, if you've got a piece of something that sounds like something else that we've heard a number of times before, it had better be doing some other work. So I don't mind a cliche. I don't mind expressions like that at all. But they better be doing something else other than just sitting there. They ought to be, um, you know, um, echoing something or indicating something. There has to be structural work. And I'm not convinced that in this description, which is, just setting a certain atmospheric stage for walking in the churchyard, You've got minutia rusting the wounded ground. That's very nice. I like the vague wind, vespered, dirt ordered itself, etc. Not blackbird's clack. That was the weak place for me. By the way, I wasn't planning to do this to
To
criticize the poem.
deconstruct it.
What? Yeah,
Oh,
I wasn't.
I'm the one that's
I just picked the
criticizing it.
poem I liked, and I was going to read it to you. I don't want somebody to be kind of insulted that I said, "Oh, blackbirds clacked." I'm sorry.
No,
No,
I'm the
really,
one
I like the
that's
poem.
criticizing it. No, I didn't mean to trash your poem. I guess I just like to talk about poetry, and I thought it was a good time, a good opportunity to talk more about it.
Sure,
But
sure, sure. No, I'm not blaming you in any case. It's
okay,
just
no, I guess it's just a tendency to go back to philosophy. Uh, when it comes to poetry, I have a taste for desert landscapes,
Ah,
and yeah, very much so. So I just thought of a poem that came to mind that captures the sort of austerity that I'm looking for. Is Alba by Ezra Pound.
okay.
And do you know that poem?
I've heard it. Yeah, I've read it. Yes, but I don't.
Yeah.
I don't remember it in detail at the moment. I was thinking of an Ezra Pound, possibly reading it to you, but that wasn't the poem. I
Well,
wasn't going to do that one.
I'll just read it because it's 3 lines, and
Sure.
it's as cool as the pale wet leaves of lily of the valley. She lay beside me in the dawn,
Okay.
and
Yeah, I remember that.
it's just so simple,
Mm-hmm.
and again, really captures something ineffable. I mean, we really took yours apart and got maybe to the ineffability of it, but I like that it does so much with so little, and it doesn't use words like vespered. Uh,
Vesper. Okay, but look, here's the
Peace
point.
to Giles or Giles.
Here's the point, really, that you're getting at. I mean, you're not saying you like desert landscapes. I disagree with your interpretation of yourself. You're saying I like desert landscapes that are rich and do a lot.
Yes.
And I don't have
Yeah.
an objection to that. And I certainly think, well, you can have a lush landscape that does a lot. But
Uh
here's
huh.
the danger. The danger with a lush landscape is that some things are there just being lushy. And they're not doing anything else.
Mm-hmm.
That we don't want. And I
Yeah.
don't want anyway. I want everything in my lush landscape to be doing a lot of work.
Mm-hmm.
That there's no excuse for something to be there just because it has rich associations or in some other way is lush. What you want is you want all that to be exploited in the poem and to do work. So
Hmm.
that's what I would say. So I'm suggesting there's a complementary aesthetic here.
Mm-hmm. And I find that I am not objecting to your. I accept your objection. I do not object to your objection
Okay.
because I mean, cliched as it is, one of my favorite authors is absolutely Ernest Hemingway,
Mm-hmm.
and his prose is very much like a desert landscape, but he does so much with it, which is what makes it so
I
powerful.
I agree. I am not a fan of his, but there are some of the stories that I think are the best were the ones about fishing. You know the stories on, and I
Yeah, yeah.
realized
I mean, I tend to think of the lion hunting story. That's one that really comes to mind.
yes, yes, but you see the problem with me and Hemingway is that he has two characters in all of his fiction, a male and a female, and
Mm-hmm.
I think it's just the same damn character over and over again. And whenever there's much character, I'm getting upset because it's those two characters. And what happens in the short story I'm thinking of is that's in the background. And what's in the foreground is his description of the fishing. And it's amazing.
Hmm.
And again, austere.
All right, Jody. Well, this has again been great. I'm sorry for bullying your poem a little bit,
Yeah.
but I thought it was I took joy in it, so I want you to know that you brought me some joy. I also love talking about your poem as well and the
Well,
philosophy
thank
of
you. No, this was
mathematics. So
fine.
I
This
said
was
I said this last time. Again, thank you for blessing my audience with your presence. Hold on, Geeslings. Before you go, please like, subscribe, follow if you haven't already. Smash all those buttons. And also, if you haven't followed me on Twitter at Robinson Earhart, or if you're not joining me every morning as I eat my pint of ice cream on Twitch at Robinson Earhart on Robinson Eats, please do so.